Hi, I'm Travis and I'm an engineer on the academic team here at National Instruments. And today I want to show you a new approach to helping students understand when to use which kinds of motors in robotics and mechatronics applications. For designing just about any mechatronic system, students will need to use some kind of motor. However, when students first learn about what a motor is, they're often only exposed to one or two types. So even students who think they know what motors are or know motors well may find themselves attempting to use, say, brushless DC motors, for instance, in a job where a stepper motor is more ideal. If we want to ensure students learn to develop complex mechatronic systems, we need to first ensure they understand the differences in DC motors from their own experience. So let's get started. In order to do so, there's some basic hardware that we'll need. First and foremost, we need motors. In this case, I have the Quanser QNet Mechatronic Actuators board. It has numerous different kinds of motors, including a brushless DC motor, a stepper motor, and an RC servo. For today's demo, we'll compare a brushed DC motor to an RC servo and see how similar motors can have totally different applications. We'll also need some measurement and control hardware. In this case, I have an NI Elvis, an engineering workstation that has data acquisition and control capabilities built in. I'll be controlling all of these with programs written in LabVIEW. So to begin, I'll introduce students to controlling a PWM amplified brushed DC motor. As I use LabVIEW to increase the duty cycle of the pulse signal that I send to the motor, I can show that once I overcome the static friction, my speed increases fairly linearly. Now it's important to point out that this is an open loop system, so the speed of my motor is running unregulated. Now with that in mind, I'll then introduce students to how to control an RC servo motor. Now it's important to tell students that an RC servo is an all-in-one motor control package containing a motor, a gearbox, a potentiometer, and control circuitry. Since this is a complete system, all I need to do is vary the pulse width of a signal I send to the servo, and the position will change accordingly. So I'm going to go ahead and close out this program and open up the VI running my servo motor. Go ahead and run that. And as I change that duty cycle, you'll see that servo motor start to actuate. In watching the servo motor actuate, as a result, students understand how to control it and its applications. So now you've seen that by allowing students to actuate various types of motors, students are better prepared to select which motor type can or should be used in their next project or application. To explore this approach further, download the free courseware link from this page.